one of the most simplest and fundamental topics in operating system, first come first serve scheduling algorithm or FCFS for short. In our daily life, we often see situations where people or tasks are served in same order that they arrive, like standing in a line at a ticket counter, waiting for, at a restaurant. The one who comes first is served first. The simple idea is first come, first serve scheduling works inside an operating system. It decides which process should use the CPU based on the who arrived first. Before we go deeper, let's quickly understand what CPU scheduling means. In an operating system, there are many processes waiting to use CPU, but the CPU can execute only one process at a time. So CPU scheduler is a part of OS that decides which process will get CPU first and for how long. The main goals of CPU scheduling are to maximize CPU utilization, minimize turnaround time, minimize waiting time, and provides fairness to all processes. There are several scheduling algorithms: FCFS, shortest job first, SJF, round robin, priority scheduling, and many others. Among them, FCFS is the most basic and easiest to understand. Now we'll go through the concept of FCFS. Let's talk about how FCFS actually works. In the first come first serve algorithm, the process that arrives first in the ready queue is the one that gets executed first. It works on the first out principle, FIFO principle. This means the process are executed in the same order in which they arrive in the ready queue. FCFS is non-preemptive algorithm. That means one process starts execution on the CPU and it will continue until it finishes. If a new process with shorter burst time arrives, let's imagine we have three processes P1, P2, and P3. If they arrive in that order, they will execute in the same order. P1 first, then P2 and P3. Example of FCFS. Like let's take a simple example how FCFS scheduling works step by step. Suppose we have three processes P1, P2, and P3. It has the arrival time 0, 1, and 2, and the burst time 4, 3, 1. Now the step 1 is first we arrange the process in the order of their arrival time. The one with the least arrival time will arrive first. Hence they arrived in the order P1, P2, and then P3. Now we'll create a Gantt chart which shows the order and the timing of CPU execution. Let's start with P1. P1 arrives at time 0 and it has a burst time of 4. So it will run up to 4 seconds. After the execution of P1, then P2 arrives at arrival time 1. It will execute after the execution of P1. P2 executes from 4 to 4 plus 3, that is 7. Then P3 arrives at arrival time of 2. It executes from 7 to 7 plus 1, which is 8. So the Gantt chart looks like this: P1 first, P2, and then P3. Now let's calculate some important times for each process. And P1, P2, P3 and arrival times are given. Burst time also is given. Completion time is 0 plus 4, which is 4. This 4 plus 3 will be the 7. Completion time for P2, and we add 1 second to the completion time of P2, which gives the completion time of P3, and the turnaround time is given as the completion time minus arrival time, which is 4 minus 0, 4, 7 minus 1, 6 for the process 2, 8 minus 2, 6 for the process 3, and the waiting time is given as turnaround time minus burst time, which is 4 minus 0, 4 minus 4 for the process 1, 6 minus 3 for the process 2, 6 minus 1 for the process 3. And these are the formulas. And the step 4 is finding the average turnaround time and average waiting time, which is 4 plus 6 plus 6 upon 3 gives 5.33. And the average waiting time is given as 0 plus 3 plus 5 upon 3 gives 2.67. And this is the example in which we calculate the average waiting time and the turnaround time. Now we'll go to the coding part. Firstly, there is function FCFS scheduling, and we have printed first come first serve CPU algorithm, and we have a process in a list which consists of a list sublist. 4 sublists are there for the process P1, P2, P3 and P4. Now the next step is to sort them by their arrival time. We are using here a lambda function which is used to sort the arrival time, and we are printing a table. In that, the heading would be process and its arrival time, burst time, start, finish, waiting, turnaround time. And we have initialized current time as 0, total waiting time as 0 and total turnaround time as 0. Now we'll loop through this. We'll loop in the n size list. We'll initialize the process name as the process I0, which gives P1 in the first iteration. In the second iteration it gives P2, in the third iteration it gives P3, in the fourth iteration it gives P4. Same for arrival time. In the first iteration it gives 0, and the second iteration it gives 1, in the third iteration it gives 2, and the fourth iteration it gives 3. For the burst time it gives 8 in the first iteration, 4 in the second iteration, 9 in the third iteration, 5 in the third iteration. We have a condition. If the CPU is idle, we'll jump to the arrival time. If the current time is less than arrival time, then we initialize the current time as a arrival time. If not, this part will be executed, which is start time equals to current time. And these are the formulas. Finish time equals to current time plus burst time. The waiting time equals to start time minus arrival time. And the turnaround time is given as the final time minus arrival time. And we'll be printing the process. We'll be printing the process name, arrival time, burst time, start time, finish time, and the waiting time. Now we will be calculating the total waiting time, which is given as total waiting plus or minus plus equals to waiting time. As we are in this for loop, after every iteration, the total waiting time will be calculated. And after the calculation of total waiting time, turnaround time, and the current time, we'll be calculating the averages, which is n is the length of the process list. And average waiting time is actually the total waiting time which we have calculated in this for loop divided by the length of the process. And the average turnaround time is actually the turnaround time we calculated here upon length of the process, and we'll be printing them average time and the average waiting time and the average turnaround time. And next part is to print the Gantt chart. We'll be printing the Gantt chart heading, and then we'll initialize the current time as 0 and the chart as this dash timeline as 0. And we'll go into another for loop, which is same as before. Arrival time will be arrival time for the process P1, P2 and P arrival, and the burst time for process P1, P2 and P3. In the process name P1, P2, P3. Again, we'll go to the same condition, which is CPU ideal condition. If the current time is less than arrival time, then chart will be idealist. If not, chart we'll be adding the process name to that, and current time we'll be adding the burst time, and timeline will be plus equals to the current time, and we'll be printing the chart and printing the timeline. When we call this function, this is the output, which is P1, P2, P3, P4 are the process names, arrival times, burst times, and this is the starting time and the finishing time. These are the arrival times, turnaround times, and the average waiting time is executed 8.75 and 15.25, and we have print the Gantt chart here. Now let's have some advantages and disadvantages. Advantages of first come first serve. Simple and easy to understand. Fairness. Each process get a fair chance because it's executed in order of arrival time. And good for batch system. Batch system is a type of operating system. It works well when processes are submitted together and don't need interaction. And we'll have some disadvantages. However, first come first serve also has some major drawbacks. Long waiting time for the short process. If the long process arrives first, then the shorter process have to wait for it to complete, and the poor performance and the conway effect. I would like to conclude the first come first serve scheduling algorithm is most basic and straightforward scheduling method used in operating systems. It works on the principle of whoever comes first and gets served best. While it's easy to implement and understand, it has limitations such as long waiting times, conway effect, foundation for advanced algorithms like SJF, shortest job first, and priority scheduling and round robin. Understanding FCFS gives a clear starting point to learn how operating systems manage multiple processes efficiently. Thank you for watching my presentation on the first come first serve. Sir.